Problem 3. Rectangle ABCD has side CD equal to 3 and DA equal to 5. A circle with a radius of 1 is centered at A, a circle with a radius of 2 is centered at B, and a circle with this radius of 3 is centered at C. Which of the following is closest to the area of the region inside this rectangle but outside all three circles? Well, this is a problem from the AMC8, so it says which of the following. But here we don't have to do a multiple choice problem, we're just going to solve for the answer directly. Let's first start by marking everything we know. CD is equal to 3 and AD is equal to 5. This has a radius of 2, radius of 3, and a radius of 1. And what are we trying to find? Well, we're trying to find the area of the region inside the rectangle but outside all three circles. So that would look like this region over here. So this is the region we are trying to find. Let's think about how we could solve for this really irregular region. Well, when solving for irregular areas, usually what we do is take a larger portion that it is part of and subtract all of the regular areas from that total area. In this case, that would really work, right? Because we have a rectangle, which is easy to solve for, and then we can subtract each of these quarter circles. And each of these quarter circles we know how to find too, by first finding the area of the entire circle and then just multiplying 1/4. So that's what we can do to solve this problem. And when solving something with lots of calculation, we need to be organized. So let's first name each region a letter, X, Y, and Z. Now we can solve for X, Y, and Z separately. What is X? Well, now we're going to solve for X first. We know that it is part of the greater circle with a radius of 3. So we can do 3 squared times pi. That's the area formula for circles, giving us 9 pi. And then take 1/4 of that, which gives us 9/4 pi. So this is the area for X. What about Y here? Well, Y will use the same thing. It is 1/4 times 2 squared pi, giving us just pi. So Y is equal to pi. And now let's solve for Z. Well, we have 1/4 times 1 squared pi, giving us 1/4 pi. So that's our area for Z. Now let's solve for the rectangle ABCD. Well, we have 3 times 5, which is equal to 15. So our final expression would look like 15 minus 10/4 plus 1, which would look like 14/4 pi, or we can simplify it as 15 minus 3.5 pi. So our final expression that represents the area of the region inside the rectangle but outside all three circles would be 15 minus 3.5 pi. This is our final answer.